Right? So this is billions of dollars at the monthly rate. We start here in August 2007. We go through June 2009. This area here is what you want to focus on. This is when the rebates are being dispersed. And so the calculation we're doing here, again, following Soundtrap here on Slambot, is we take the MPC that's estimated in the microdata for new motor vehicles, 0.36. We multiply it by how much of the rebate are given out in any given month. We allow for some lag effects of that spending. So not all that spending is happening immediately in 1 month when you get the rebate, some happens later. And that's essentially going to be our sort of partial equilibrium calculation, or from, based on the microestimates, how much does the rebate change demand for new motor vehicles? And so then what we do is we subtract that from the realized data, and that's the purple line. So one way you can think about this is that just based on these micro MPCs, we're constructing here a counterfactual. What would have happened to aggregate motor vehicle spending if these micro MPCs also apply at the aggregate level? And so what you can see is this counterfactuals is really stark, right? We have a 90% drop in new motor vehicle spending, followed by a really swift recovery, to the point where our motor vehicle spending after the Lehman crisis, a big macro shock, is much higher than it would have been absent the rebate, according to this counterfactual. So this is the tension that we're trying to get. Now, of course, this is a simple calculation. We're not allowing for any general equilibrium effects in this in here. And so this is one of the first things we're going to address in this paper is do that. So what does our paper do? We're going to construct essentially these kind of macro counterfactuals, what would have happened absent the rebate, using a medium scale New Keynesian model. So we try to be here pretty standard. We're going to have some non-standard elements, I'll introduce you to, but really we're trying to be pretty off the shelf here. And so what we're going to argue is that if you just take these off the shelf models, calibrate it to the micro evidence, you're also going to get these kind of implausible counterfactuals similar to the ones I've shown you on the previous slide. Now, before I tell you sort of what do these counterfactuals look like and how do we ultimately resolve this tension, let me just say a few more words. Why do we look at 2008 specifically? We already started looking at other dates, but 2008 we think is the best way to kind of, or the most convincing way to look at this joint micro and macro perspective, because the rebate was just really large. It was about 11% of monthly disposable income. And so it's something you can see in the macro data. I'm going to show you that when you look at the graph disposable income. It's very obvious there. And we think relative to the other rebates dates, well, we are looking at them, but we think this is sort of the cleanest one. There's a rebate in 2001, but immediately after, the month after the rebate starts being given out, 9/11 happens. So it's going to be a little hard to tease that out in the macro data. And obviously 2020 and 2021 stimulus checks, COVID is happening at the same time. So that's sort of a fairly tricky episode to look at. So we think 2008 is sort of the right first step to take here when thinking about these ratio between the micro data and the macro data. So what do these counterfactuals look like? This is now going to be a counterfactual for total personal consumption expenditures. Right, so before I've just shown you motor vehicles, but in the model we can do it for everything. So the black line here, this is the actual data. Again, this is going to be $1 billion at the monthly rate. I'm only looking at 2008 data. The rebates being given out between mostly April and July. And then for various levels of the micro MPCs, we're going to give you counterfactuals, right? So I'm going to show you the model that gives you this. But the bottom line is that we're going to argue here is if you take sort of a typical MPC like 0.7 that you get out of the microdata, or even 0.5, you're going to get these kind of sharp drops in consumption expenditures, followed by a swift recovery and lower consumption during these periods while the rebate is dispersed according to this counterfactual than you would get after the Lehman Brothers hits. Again, it's something that we don't think is particularly possible. So then how do we, okay, why do we think it's particularly plausible? Well, you can calculate how much is consumption decline over a 3-month period based on these various values of the MPCs I've shown you. So you get a 1% decline, a 2% decline, a 3.2% decline based on these different values of the MPCs. Maybe that doesn't sound so big to you, but when you look at the history of the United States in the post-war data, when do you ever see declines like this? Well, the only decline that's bigger than 3.2% over a 2-month period is COVID. And if you want to get a decline that's larger than 2%, well, you actually have to work pretty hard. You have to have shocks and the order of like this credit controls plus Volcker raising interest rates at the same time. There's 2 more episodes where consumption drops on that same order of magnitude. But that is the temporal substitution. This just follows there's a spike up and there's a spike down in the data. And so again, this is not something we think is, so again, the point I want to convey here is that these kind of counterfactuals are actually pretty stark. And again, we don't think they're particularly plausible. So then how do we reconcile the microestimates with the macro counterfactuals? So we're going to go through 4 different arguments in the paper. The first 2 I'm going to focus on first because we're going to rule them out. Let's put it on the table. So maybe there were actually, maybe these counterfactuals are plausible. Maybe there were factors that led to really sharp drop in consumption in May and July, much lower consumption than you would have later after Lehman Brothers fails. So I'm going to try to convince you, based on the available evidence, that that's not particularly realistic. We're going to look at narrative evidence and forecasts tonight. Another explanation for the disconnect between the micro and the macro data is that there's measurement error. So maybe in the aggregate data, there is actually a spike up, but we failed to measure it. The BA, when it constructs its data, it smooths out these kind of high frequency spikes. And so that's why we're getting these implausible counterfactuals. Again, I'm going to try to convince you that based on the available evidence that this also doesn't look particularly plausible. So then the 2 explanations that we're going to center on are going to be twofold. One is this has to be an important general equilibrium dampening force that sort of essentially is going to allow for relatively high micro MPCs, but those translate to just less aggregate spending when you would expect just based on the micro MPCs alone. And so here the key mechanism we're going to focus on in this paper is that there's an upward sloping supply curve for motor vehicles. A lot of the spending in the microdata occurs in motor vehicles. And so if a lot of spending occurs in that, you'd expect there's some congestion there, that the price of motor vehicles goes up and that will crowd out motor vehicle spending. And so we're going to provide evidence that this channel is going to be quantitatively important. It's not going to be sufficient. It will help in sort of reducing the tension between the micro estimates and the macro data, but it's not going to be sufficient. And so then the last part of the paper, we're going to look at the micro estimates themselves, and we are going to argue that sort of standard ways of estimating those using more or less different estimators overstate the micro MPCs. There's an upward bias in the estimator, and it comes from using previously treated households as a control group. I'm going to tell you why that's problematic, but for now, what I'm going to tell you is that when we use an estimator that essentially drops that control group, so it solves that problem, the MPC estimates are much lower, 40% or more. They decline by 30% or more. So what I don't want to go through is essentially just kind of convince you of these 4 arguments. Right? And so that's where the main part of this talk will start. I guess before I get into the meat of the paper then, are there sort of questions about our approach, what we're trying to accomplish? Oh, whether that's clear.
Johannes here, Jorge Miran Pinto from the bank. Hi. So there is a lot of heterogeneity in the estimates, also but also across households, right? If you look at the average MPC, it's not that large as 0.9, right? It's 0.3, but I guess you're focusing on durables, and the whole story will be about the durables MPC that seem to be really large.
Yeah, so if so it depends exactly. So the composition of spending here is going to be very important. That's exactly right. So the original Parker estimates are somewhere between 15 and 25% of the MPC. So the MPC on non-durables and services like 15 to 25%, and the MPC on durables is going to be like 35 to 50%. Something like along this order of magnitude. So we're going to take all of that together, right? So that's the total MPC. Now in our model, the main general equilibrium force here is going to operate on the durable component of that spending, because that's where the general equilibrium force is more important. Durable spending is more elastic than non-durable. Now it turns out there was no reason to expect this ex ante, but it turns out that this upward bias turned out to be more severe for the non-durable component, and so. It turns out that again, ex-ante that wasn't obvious. Well, I guess maybe this part was more obvious, but the general equilibrium forces sort of shrink the aggregate effects of the durable spending. And then on the sort of non-durable and server side, it turns out that those were just overestimated by the standard estimators. Okay. But yeah, exactly. That distribution of spending is going to be very important. That's right.
Hi, Luciano Villacorta here from the bank. Just one curiosity regarding that last point. Here you're referring to the bias that appears when you use this diff in diff, but you are thinking that the real data generating process, like heterogeneous MPCs, is that? And you're trying to like a model with random coefficients or heterogeneous effects, and you are trying to estimate the average effect. And this is what is happening here, or is something totally different?
So the problem we identify here, or the main problem we identify here, actually occurs even in a homogeneous effects model, and it's coming from the staggered treatment. And I mean, the problem is that the houses that were previously treated, they had high consumption in the past, and so their consumption path is declining generally, and that's going to be used as a counterfactual for households that are getting the rebate now. And that's the problem. You would have that problem in a homogeneous effects model. Now the question is, how do you handle that problem? In a homogeneous effects model, you can introduce lags, and that's something you can do there. In a heterogeneous effect, that's not going to be sufficient. And so we do find that these treatment effects are actually heterogeneous across the households if you look sort of by treatment date. And so so just drawing that out as a control group is just a cleaner way to handle the problem. So hopefully that will be clearer once we get to the point, but I'm happy to pick up that conversation again when we get to that.
Thank you.
Other questions? Okay. Right, so then let me jump in. I'm first going to sort of set the stage here for what's happening in 2008. It's been a long time now. It's useful to remember what's going on there. Then I will go into the sort of first two hypotheses of like maybe we should have expected a big drop in consumption absent the rebate, and I'll also get into these measurement issues. Then I'll talk about the model we use for aggregation. So I'm going to first want to throw out these kind of ideas, and then into the MPC estimates. Okay. So 2008, what's going on? The main thing we're going to be focusing on is the rebate itself. Now, the origin of the rebate is in December 2007, there was a fairly bad employment report being released. At that point, people were worried that the economy is going to start getting into a recession. So this is way before Lehman. Like Lehman happens almost a year later. The rebate itself was passed into law on February 13th. Again, it's big, $100 billion, 11% of monthly disposable income. How much you got depended on how wealthy you are, how many kids you have, whether you file taxes. We're not going to do a whole lot of heterogeneity. At the end of the day, the average check that a household got was about $1,000. If you want to look at the time path of the disbursement, this is what it will look like. So here we have January 2008. The first payments started going out in April. These were pretty small. They essentially went to Puerto Rico. They're not going to be in our sample when we do our microanalysis. The big disbursements really start in May 2008. That's where all the electronic payments are being made and some of the first sort of checks are being mailed out. Almost half the rebate is being distributed in May. And then most of the remaining comes in the following 2 months. Right? So it's a pretty high frequency event. Within 3 months, most of the spending is done. And so you can visualize sort of whether something is going to be there in the graphs I'm going to show you. We're going to mark May 2008 when this big spike happens with this red line. And so you'll see that in the following graphs as well. So let me then show you sort of the analysis that Feldstein and Taylor did. So on the left here, I'm showing you disposable income. And so how much money do people have available for spending? We start in July 2007 here. We go to July 2009 over here. Again, the key part is going to be right around that red line, May 2008. That's when the big spike in rebates are being given out, $50 billion. You can see that pretty clearly here in the day. Spike up in spending, and then a little bit more in the following 2 months. The blue line here is real. The green line here is normal, and either one of those you see the spike in income coming from the rebate. Now the right panel here plots consumption expenditures. And so to make this comparable, the way you're going to do this, the width of the y-axis here, $80 billion, that's exactly the same on both sides. Right? So you can sort of compare magnitudes. When you look at the real data, it just doesn't look like really much of anything is happening here. Maybe there's a little hump, maybe, but the kind of magnitudes are nothing near the kind of spike up you've seen over here. Now, obviously, this is not perfect identification, but this is the kind of analysis that Feldstein and Taylor did, and said like, well, look, you look at consumptive expenditures, it doesn't look like there's a lot of action here, so maybe a lot of this rebate was actually saved. Now, the real consumption expenditure data is perhaps sort of clearer here, in that it really doesn't look like there's much action. On a normal side, maybe there's some more, right? So there's this sort of hump shifting up. I'm going to come back to that. What's driving the difference between the nominal and the real? Obviously, that's a price index, right? So that's just kind of by definition, but we don't think that's being driven by the rebate either. And I'll tell you why in a little bit. The next thing I just want to show you is you can dig into sort of various components of consumption expenditures. Like you can look at non-durables, you can look at durables, you can look at services, and there's nothing really particularly here that jumps out as like, where's the spike in spending? If you think that 50 to 90% of the rebates being spent, is kind of surprising, but there really is nothing sort of jumping out here. Again, maybe there's sort of small movements just around that date, but know that the magnitudes are just tiny. Like we're taking maybe like $1 billion here, maybe $1 billion here. We're being generous, right? It's really not very big. There's nothing really that jumps out in the macro data that the effects of the rebates were large. Now, again, we're not computing a counterfactual yet. I'm just giving you sort of the raw data as it is. Let me just go back to this point of, okay, why are we seeing maybe a sort of hump in nominal expenditures, but not in real? Well, obviously the difference is the price index. And so the blue line here, this is the price index for total PCE. So following May 2008, you see that big hump here, that difference. If you just look at core PCE, that same hump essentially is gone, right? So that tells you this is energy or food. It turns out it's energy. Oil prices were spiking over this period. This is the right panel. We don't think those were driven by the rebate. Those are determined in global markets and the rise of emerging economies at the time. Now again, that disconnect here between nominal and real, we don't think that's really driven by the rebate itself. Okay. Now, let me skip this part. So what's happened in 2008? Well, it doesn't look like there's a big rise in consumption. There's maybe a hump in nominal expenditures, but that's really driven by oil prices at the time. The monetary policy is not doing a whole lot over this period. Just quickly go through that. The nominal interest rate declining over this period, then remains flat, and then declines some more after Lehman Brothers fails. Real interest rate just kind of bottoms out. So in terms of real interest rate action, there's really not much happening here. Let me get into the measurement issues now, right? So there's nothing really obvious that jumps out in the aggregate data, but maybe we're mismeasuring that. Maybe there is actually a spike up in the true data, but in the measured data, it's not. And so the concern here is specifically that the BAA, when it constructs measures of personal consumption expenditure or aggregate income, what it does, it targets a level, right? It doesn't target a change, right? So it tries to estimate gets the best possible estimate for the level. And when you do that, you may be smoothing out some high frequency moving that's actually there in the underlying data. So what we're going to do is we're going to sort of look at various high frequency sources that we think do not suffer from this drawback and see how did they compare to the official estimates. So on the left panel here, what I'm showing you is personal consumption expenditure for goods and total expenditure based on a retail sales survey from the US Census. Why are we comparing these? Well, we know the total retail sales, that's the raw data, that's what the census reports to us. And this is the main input that goes into the BA estimate for personal consumption expenditure for goods. It's primarily based on the retail sales survey data. And so you can check, well, is there maybe some high frequency movement in retail sales that you don't see in PC? And so you look over this period from 2007 to 2010, and these series just track each other really well. It doesn't look like the BA is doing a lot of like additional transformation here to the series. If you want to zoom specifically around May 2008, again, when the rebate is being given out, it doesn't look like there's anything anomalous there either. So,
Johannes?
Yeah.
This is Gustavo from the bank.
Yeah.
Couldn't you have looked at like some sort of regional evidence, like to see if in some states in which like the crisis was not as severe as in others, maybe you do see something different going on, and maybe like I don't know, like there is some sort of heterogeneity along those lines where basically you can better identify in the aggregate what is going on with the MPC, or maybe like look like basically gathering some more action from that.
Yeah, I mean, so the way we're trying to get at whether there was sort of some underlying weakness in the economy that the rebate may be propped up is, I'm going to show you that later. We are going to use some forecasting models, and we can look at professional forecasts. We haven't looked at regional data. It's something we should think about. It's not clear to me immediately how we would handle it.
I was just thinking that maybe
question, I guess the question is, you're thinking that the effects of the rebate vary depending on the severity of the I guess underlying economic conditions. Is that so it's like a heterogeneous treatment effect kind of model? Is that what you have in mind?
I was thinking more broadly, like in terms that basically many of these aggregate patterns could be like polluted by some concurrent aggregate shocks to some extent, and maybe like you have some states in which you don't have those concurrent or negative aggregate shocks, and some states in which you do have them, and basically that difference in the aggregate could illustrate better things about MPCs.
I mean, we could look at it. We could certainly do some cut based on like kind of the Mia and Sufi measures, for instance. We haven't looked at that. I think that's a reasonable exercise for us to do. Let me think about.
Yeah, I mean, not exactly like that, but it was like getting the idea from these like very very known paper by Nakamura about fiscal expenditures in a monetary union, where she uses like this military spending to gather a sense of like the effect of fiscal expenditure on GDP at the regional level. So maybe like not doing something like as rigorous as what she does in that paper, but something in the spirit of that could be useful.
I mean, we can certainly break things out. And we have state level GDP, and we have certainly state level expenditure data too. So we could break things out and see whether any state shows anything. Certainly something we can look at. And I think probably the most plausible, because the main weakness here is in the housing sector at the time. So maybe doing a cut by that would be useful. So make a note of that. Okay, let me just finish here on the measurement exercise. So retail sales, we don't really see a lot of smoothing here. The other exercise we did is we just aggregated the consumer expenditure survey, which is the survey in which Jonathan Parker and his co-authors estimate these MPCs, and we asked, well, maybe there's a spike in expenditure there, right? And it turns out, if you look at May 2008, there's really nothing unusual going on there either. So even that survey itself does not show a spike in expenditures at the aggregate level once you aggregate it. Lastly, you can look at motor vehicles. Motor vehicles we measure extremely well. I mean, there's essentially zero measurement error in this stuff because all that stuff has to be registered with the DMV, and then they can pass all that on to the census. And so there's maybe a little uptick in unit sales. It's not very big in the grand scheme of things. If you look at a volume of sales, though, again, there's not really a lot of action here. Look at the units here, maybe $1 billion, $500 million if you're generous. There's nothing really that jumps out here that suggests that there's a big spike in expenditure that we're failing to measure. So we think the measurement error story is just not a plausible explanation for why there's this disconnect between micro and macro data. Now, that is the second story on the table, which is like, maybe there is some weakness in the economy at the time that we're not accounting for, specifically around the time that rebates are happening. That was pushing down the economy, pushing down expenditures, and the rebate is propping back up, and all that we see is the sort of flat line that I've shown. Right. So the way we're trying to, obviously, it's not a very straightforward thing to get at. So the way we try to address this hypothesis is in two ways. One is we're going to look at professional forecasts. We're going to ask, okay, what do they think was going on? What were they forecasting what's happened to the US economy before they knew about the rebate? And so here, what's important for us is the forecasts were already starting to get pessimistic before the rebates were getting passed, because the employment reports were already getting worse at the time. So we can ask, okay, what were they predicting, and use that as sort of like, okay, can we sort of estimate, what would a reasonable drop in consumption look like over this period? Now, some of the forecasts, especially the ones later on in the sample, predict there would be a rebate later on in the second half of the year. So for thinking about how much would consumption fall in the second quarter of 2008, that's still okay for us. But generally, we try to focus here on forecasts that were made before the rebates were passed. Our second approach to this issue is we're going to construct our own time series forecasts. And the name of the game here, we're trying to make them as really as pessimistic as possible, like based on sort of historical consumption patterns, and giving you all kinds of information of just how bad the state of the economy is. How bad can we make these forecasts? And so that's going to be our second approach to this issue. So these are the professional forecasts. What we have is the black line here. This is the realized data. This is quarterly now. This is the way the forecasts come to us. And again, the units are going to be the same as what I've shown you earlier. It's billions of dollars at a monthly rate. So let me start with the Fed forecast. So the Green Book forecast. This one is from January. The sort of olive green and so the more neon green is from December. They don't actually forecast any decline in consumption at this time. Even knowing that the employment report was bad, they were not thinking that the economy was weak enough to see a drop in consumption over this period. Neither did the SPF. We take the medium SPF forecast, which is the blue line over here. No drop in consumption was expected here. You have to go to the most pessimistic forecast in the SPF, which is the light blue line, or the Goldman Sachs forecast, which is the purple line, to actually get a forecasted drop in consumption over this period. But again, one way to notice is how small the difference here is. Right? So if you think of these as sort of counterfactuals, the difference here is maybe $5 billion. Right? It's a drop in a bucket when you think about the rebate being given out as $100 billion at the time. Right? So the forecast not suggests here that we should have expected a big drop in consumption expenditures followed by a rapid recovery. It's just not here in these professional forecast models. We then try to essentially make a forecast super pessimistic by running our own forecasting models. Obviously, there's a lot of ways to do this, but we really tried a lot of things here to get consumption down. So let me just highlight sort of a few things that we do. We're looking at sort of the post-Volcker recession era, and excluding COVID too, we take that out. The main variables we have in our forecasting model are consumption, disposable income, the price index, and the excess bond spread. And then we're going to add a few other variables, and these ones we're going to play around with again to make these forecasts sort of pretty pessimistic. Now, how do you make a forecast very pessimistic over this period? Well, you're going to allow the forecast to capture the Lehman bankruptcy. That's one way to make it very pessimistic. If you include a dummy in your forecasting model for Lehman, that's going to be a very negative dummy. And so if you can forecast based on that, that's going to make your forecast more pessimistic. The other way, we're also going to tell regression that we're in a recession. That's also going to make the model very pessimistic because it sees it, historically, when you're in a recession, consumption growth is low. And so we're going to do that. And then the last thing we do is we're going to tell, or the sort of last option we want to operate on is, what are we going to do with real oil prices? So real oil prices are rising over this time. And historically, that would have meant that consumption is falling. Right? So if you give the forecast model the actual path of real oil prices, that's also going to make it very pessimistic. And so ultimately, the most pessimistic forecast we can get is we're going to tell the regression model about Lehman, and we're going to feed in the realized path of real oil price. That's our sort of our first model I'm going to show you. That's our most pessimistic model. We then do various specifications where we don't include Lehman Brothers, where we feed in sort of a forecasted path of real oil prices based on the actual dynamics we see in the data. Those will be less pessimistic. And so we're not going to focus too much on those. So again, we're going to have our units are billions of dollars at a monthly rate. Black line is real, is the real actual data. And then all the other lines are different forecasting models. Again, what I want you to focus on is just focus on the lowest lines, right? What do our most pessimistic models say here? So model A here is the Lehman dummy, so that's going to get very bad over here. And we feed in this path of real oil prices as we observe it in the data. And that's also going to lower consumption. Now, again, the kind of drops in consumption you get here are not very big, right? So relative to the realized data, maybe 2 billion here, maybe another 2. You don't really get big drops in consumption here, like the kind of counterfactuals that the high micro MPCs will imply. Okay. So this is sort of the next part I want to then show you is that when we feed in the micro MPCs in the model, we're going to get counterfactuals that are just much, much worse than this, even sort of our most pessimistic forecast. But maybe before I get into the next issue is, let me see, are there any more questions about where we are and where we're going?
Hi, Johannes. Martin from the back. I was wondering whether another potential hypothesis could be that the rebate was anticipated by consumers, and whether you could see something. I mean, it didn't show up very clearly in the data, but whether you could try to also use this forecast for the periods before and see whether when this conversation started to happen, I guess in Congress, whether like people knew that because it was a big recession, they were going to get some sort of help, and therefore they anticipated consumption, and therefore we didn't see it afterwards, or something like that.
Yeah, I mean, so we've been worrying about anticipation effects. I think in this context, it's in this context of these forecasts, it's not particularly. I don't think it's particularly big issue for these forecasts because they mostly were made before they knew that the rebates were coming, and so right. So we're starting here before the rebate comes along, and so maybe to the extent there are anticipation effects, you worry like, okay, maybe April and March, you maybe see something there, but there's really not much there in the data either. Again, these units, the magnitudes are pretty small. In the microdata, we try to look at this, right? So I mean, obviously there's sort of limitations in what you can do because if all the anticipation effects happen at the same time, it's just going to be differenced out, and you can't measure them. But you can look at whether there are anticipation effects that vary by when people get the rebate, and we didn't find any evidence of that there, and at least not in the CX. Borsak, Jarvel, and Spf, when they look at the Nielsen data, which is sort of much more high frequency, they really find no evidence of anticipation effects. It's actually really remarkable that there's like, it's essentially like the spending patterns are flat, and the moment you get a rebate is the spike up. So that sort of pushed me towards the view that I mean, in the CX we're more limited. Right? We don't have that kind of precision that they have. But that pushed me towards the view that I don't think the anticipation effects are likely all that important. Now I don't think we can rule it out completely, but I think the balance of the evidence suggests that that's probably not a big factor here.
Great, thank you.
Johannes,
Yeah.
Have you thought about the regional heterogeneity? So the Murphy, one of my co-authors, has a nice paper on this rebate that you find a lot of heterogeneity, right? So in cities or counties where there was a lot of debt, you do see large spikes in auto registration, new automobiles. So you don't have the issue with the price index. So that can, an aggregate can all cancel out, right? If this is something you can look at.
So let me just try to. So I'm not familiar with this work. This is using variation in the rebate across cities.
Yeah. I mean, this is a Restat paper, 2017, I guess. Yes. And they have heterogeneity at the city level on consumption, new automobile. Yeah, I can send you the draft later, but
That would be useful.
that's something that immediately thought, right? So you can have the aggregate data pretty much like was with lots of regional.
Yeah,
action.
I mean, I think in terms of at least the offsetting general equilibrium forces that we are stressing, and that's actually specifically on motor vehicles. It's not right. It's a question of where do you think the congestion, where's the supply curve upward sloping? Is it the supply curve upward sloping at the regional level or the national level? It's probably a bit of both, but I would imagine that it's, I guess, one might be able even to test this. No, but if the cars are just being shipped around, so you have elastic supply at the regional level, that wouldn't get at these congestion effects that we're trying to get at. I mean, but we should look at it. Definitely look at it.
You can complement their story with your mechanism. That would be interesting.
Yeah. It will certainly tell us something more about the way, at least it will tell us something more about the way the mechanism works, at the very least. So that's very helpful. Thank you. Okay. All right. So,
One last question, Enzo, from the Banco also. I have a question regarding this idea of compounding factors and this lack of negative forecast or very negative forecast for consumption. So, was thinking compared to 2001, let's say.
Sorry, I couldn't. The microphone was cutting out. I couldn't quite understand the question.
I'm trying. Is it better?
Somewhat.
Sorry. Okay, I can set this to switch to the phone. Is more audible now?
Yeah.
I can also write it in the chat later.
I think it's good now. I can hear you now.
Okay, so the question was about this idea of other episodes having more confounders, more confounding factors, perhaps, and also related to this lack of negative forecast for consumption. So I was thinking, what was the rationale for this rebate in the first place? So if consumption was not expected to drop at the time, or let's say before the approval of these rebates, so what was the expected effect of this rebate, or what was this trying to avert? Because there was no, if they were not expecting a drop in consumption, then why the rebate in the first place?
I mean, I think one thing to keep in mind is that having actually a fall in the level of consumption is extremely rare in the post-war data. Actually, let's be precise here. Personal consumption expenditures in the post-war data really don't fall very often, especially like non-durable consumption and services fall, I think, twice before Lehman Brothers fails. So there's like 60 years of data. People recognize that there was a weakness in consumption growth. That doesn't mean consumption is actually falling. is just below trend, right? So if you can, your consumption growth is 1% rather than 2%, that is, and I think they were, I mean, and that's more what they were worried about, is like maybe consumption falls from 2 to or 0, right? So that's not such a slowdown when 60% of your GDP grows at 0% rather than at 2%. I don't think. I mean, again, like 2001 is a useful comparison. In 2001, consumption growth was also not falling, and they were still giving out the rebates too. Yeah, I thought they were thinking of this as a useful way to essentially do a macro stimulus that's fast and it's hopefully somewhat effective. But again, like I think in terms of like why are counterfactuals, why is it so hard to get falls in consumption? Because they're just really rare in the data. For durable, obviously durable expansions, you see that happening more often. People stop buying cars. But for non-durables and services, which is the majority of the consumption for CE component, that essentially almost never declines. It can slow down, the growth can slow down, but it almost never declines. And that's why it's so hard to get this forecasting model to actually get you like substantial drops in personal consumption expenditure. You really have to tell them a lot of information, like we are in a recession, your oil prices are falling, Lehman is going to come, those kind of things to even get like a modest decline, I'd say, in consumption expenditures. So I hope that got the question someone. Okay, so and the way I would like the summary of what I've done so far, or what I've shown you so far, is we don't think there's really substantial measurement error in the data, and maybe you can justify a small drop in consumption based on sort of the underlying weakness in the economy, but not something particularly big. I mean, maybe 5 billion, but if you're being generous. Right? And so now let's see what our model says. Like, what would our model imply about the counterfactuals based on these micro MPC estimates? We try to be pretty just really off the shelf here, right? We didn't want to do anything too fancy. Just take those standard ingredients as much as we can. It's going to be a medium scale New Keynesian model. It will have two goods. There will be a non-durable good and a durable good, and the durable good here will be motor vehicles. And there's going to be two agents. There's going to be a Ricardian agent that doesn't respond to a rebate, and there's going to be a hand-to-mouth agent that will, and that's going to give us the MPC response. At the end of the day, this model really is Gali, Lopez, Salido, and Valles, with some extensions that Valerie did in her work, sort of meshed with my work with Alistair that will focus on the durable side of consumer expenditures. And so that the main goal we have when we constructing this model is we want to match the microdata really, really closely, right? So we want to match essentially the micro MPC estimates exactly, and then see, okay, given that change in demand that you have at the micro level, what does the model predict once you have all these general equilibrium forces? What does it predict about what should happen at the aggregate level? And so that's the robot. Let me introduce sort of the non-standard elements here, and then I'm going to give you just a brief highlight of what the sort of standard elements are. So we're going to have our optimizing households. It's going to be fixed fraction, 1 minus gamma. They're going to be fully Ricardian. They're going to get utility from non-durable good C and a durable good D, and a dislike working. One thing that's a little less standard here is the exponent on the durable good here can differ, and I'm going to tell you later exactly how we calibrate that. So, exactly what that elasticity of substitution is will be important for how this model aggregates. The budget constraint of the households, they can accumulate liquid assets. Those are A, they spend on durable consumption, they earn wage income, they spend on durable goods. So that's expenditure on new durables, X. If you hold a durable stock, you have to pay some maintenance cost on it to get the durable service flow. So if you want to drive your car, you have to pay for gas, you have to pay for insurance, you have to pay taxes and all that. You get taxes and transfers from the government, that's the T, and then these optimizing households get their profits from the firms in this economy. The durable stock accumulates based on accumulation occasion. So this is a durable stock today. It depreciates at rate delta. I'll tell you about this apparently in just a second. And then you can buy new durable goods. So X here is expenditure of durable goods denominated in non-durable units. And so if you want to have the real durable quantity, you have to divide by the relative price of the durable good. So that's P. So what's this FP over here doing? This is sort of the non-standard element here. What it effectively does is it reduces the duration of the durable good. And so one of the key features or one of the key moments that we need to match in the model is how elastic is durable demand to changes in prices. And that depends a lot on the duration. Right? If your durable good is very long-lived, then you're going to be very sensitive to small changes in prices. What we're adding here is we're essentially adding sort of one way to think about this is a sort of stochastic trading cost, right? So every period, there's going to be some of us that are going to be hit by the Calvo ferry and tell us the car that you have right now that no longer matches your needs. You now have your kids, so you have to sell your sports car and buy a minivan. Right? So you sell your sports car, you buy a minivan, and in that context, you have to pay a cost, a fraction of the value of a durable stock. Okay. Now, it's a representative agent model, so all this stuff gets sort of aggregated at the end of the day, so there's no aggregate risk. But that's sort of what this cost will represent. This is what Alistair and I did in our model, where you do actually have the heterogeneity in the fixed cost model. And it's exactly for these reasons, to reduce the interest rate or price elasticity of durable demand. I'll tell you in a little bit exactly how we calibrate that. But that's sort of the least standard element that we have here in the model. Yeah.
Johannes, this is Gustavo again. I have a question, basically, like, I don't know if this is relevant, but from what I know about the literature, like there is this setup by Kaplan and Wieland that have like two assets, one liquid and one illiquid, and people differ in their holdings of those assets. And they are able to match like the estimates by Parker and other authors. And I was thinking that, I don't know, how much does it matter that you deviate from that framework in order to basically understand the counterfactual implications of those estimated MPCs?
Yeah, so I think the way I would say I would view those papers is like there's sort of different objectives here, right? What we're trying to do is we're constructing a macro counterfactual, right? And so what is important for getting that macro counterfactual right is that we exactly match the so micro MPCs that are estimated in the data and their dynamic pattern. So the model that we're building is exactly geared towards that. It's going to be sort of pretty simple on the dimension of heterogeneity on the household side. It's going to be rich on the dimension of heterogeneity on the good side, so we have more goods, and so you can look at sort of different spending on that. But the goal is really to match sort of what's the change in demand at the micro level, and then think about the aggregation of that, right? And the change of demand we exactly match. Now, what is our model not good for? Our model is not really good for thinking about what if the rebate was twice the size, or what if it was half the size? Then we would need different micro MPC estimates based on that. We would need to feed them in, right? We would have to change the calibration of the model, right? Our model is geared to look at exactly this episode and aggregate it up, right? And that's why we make the choices we make. The Kaplan and Wieland, what they can do in their model, they can think about, okay, let's scale up the rebate, maybe scale it down and see what are the different effectiveness of those. But obviously that comes at a cost, is that you're imposing a lot of structure and you can't match the micro estimates as well as we can, especially not the dynamic pattern, the anticipation effects to the extent they're there. And so you're essentially operating in a different trade-off space, given the different questions that are being asked. So again, in the context that we don't think that having all the heterogeneity or the very complex household level heterogeneity that they have is very important for the question that we're asking, which is take the change in demand as given. Right? We get that from the micro estimates and aggregate it up. But if we're happy to hear arguments, right? So this is at every talk we're tell us where we might be going wrong, because we run it here now, but in the referee reports. So if there is a part where you think we might be going wrong based on this particular aggregation approach,
not really. I mean, I was just curious about it, so I was happy to.
I mean, it's sort of more broadly, right? I do think it's like this is relevant for us.
So sorry for jumping in. This is Ernesto. So there is one dimension that I can see that the two models can get different predictions, which is when someone gets the rebate, whether it's going to prepay debt or it's going to relax the budget constraints somehow. I don't think that that is going to kill the whole thing, but it can be sizable in some context.
Yeah, but this would be captured in the MPCs that we calibrate to, right? So if everyone were just repaying debt, the MPC would be 0 that we measure in the microdata and we just calibrate to that, right? So to that extent, that's where we think like exactly calibrating to micro elements is the right approach here for thinking about this aggregation question. And so, you know, if it is more people repaying debt, in the way that was reflected in our framework, there would just be fewer hand-to-mouth consumers, right? There would be more optimized consumers. Now, maybe that's not sort of strictly the right interpretation given what the mechanism you described, but in terms of thinking about, okay, how much demand is being created and how does that aggregate, I think would still be okay. Because at the end of the day, what matters for that is like, how much does demand change? And then how do prices adjust and how elastic is demand to prices? And those are exactly the kind of moments we target, right? So those are exactly the things we try to get right. Okay, so let me zoom through a little bit more so we get to the good stuff. So we have a hand-to-mouth consumers. Usually the way you model hand-to-mouth consumers in DSG models just consume everything right away. And we're gonna allow for some sort of more smoothed out spending. So they can spend some fraction this month, some fraction next month, some fraction the following month. Eventually they're gonna spend all of it, but it doesn't have to be all immediate. And again, we're gonna calibrate those to match the micro evidence. Durable production, this part, actually no, I shouldn't skip this part. We have a micro foundation for essentially the supply curve of the durable. The micro foundation is not particularly interesting. So let's tell me what the result is, which is the relative price of durables is increasing in durable expenditure based on the supply elasticity, and the supply elasticity is data here. So there's some congestion here. We have a congestion externality in the model. You could have a fixed factor in production. When the supply elasticity is not infinity, that essentially means you can't just take non-durables and convert them to durables or vice versa, right? So there's some cost that has to be paid there. The remaining elements, super standard, sticky prices, sticky wages, adjustment cost and investment, variable capitalization. The one thing that's maybe a little bit more important is obviously giving a rebate creates a deficit. And so you have to specify how does the government deal with that. We're just going to push that far in the future. That's going to be happening at least a year from now. They're gradually going to raise some prices to pay that down. It's not going to matter for the dynamics that I'm going to show you now. Okay. Calibration, again, the goal, as I've told Ernesto, is we want to be very, very clear about matching the increase in demand that comes based on the micro estimates, and then be very cognizant about getting the right price elasticities here to get the general equilibrium effects right. The baseline model will have perfectly substitutable non-durable and durable goods, so that supply elasticity is infinity. That's the baseline assumption that's being done in the literature. We're going to relax that later on. That turns out that that's quite important. Our hand-to-mouth consumers are spread consumption base. They're going to spend 2/3 in the first month, 1/6 in each of the following months. We've done various different cuts here. Obviously, the estimates, there's standard errors around those. So we think these are the best estimates. We tried various different ways, and that really doesn't matter very much for what we're after in the end. We can directly calibrate how much spending occurs on durables. We're going to calibrate that to 83%. That's based on our estimates that I'll show you in a little bit. Again, we can directly parameterize that because our goal is here to get exactly that increase in demand. And then the demand elasticities are obviously very important. When the price of durables goes up, how do people respond to that? We're going to calibrate this durable trading cost and the elasticity of substitution, this exponent in the utility function, to match two moments. A long run durable demand elasticity of -1. That's very typical in the car literature. There's a range of papers that sort of estimate values around that. And the short run durable elasticity we're going to get from Rudy Bachman's paper. There's a whole bunch of co-authors there that I don't remember who else is on that paper as well. Okay, so then we're going to feed into our model the realized path of rebates. We're going to match exactly anticipation lag, the size, the timing. And they're going to get all that exactly as it was in the data. We linearize the model, right? So the model is going to spit out a % deviation from an economy without rebate. And then we're going to subtract that percent deviation from the actual data to construct a counterfactual. So that's the way it's going to work. And we're going to run this for a range of MPCs, 0.5, 0.7. Those are the sort of typical estimates you would get in the literature. 0.3, this is going to be our preferred estimate, and some other work suggests that that's also more reasonable. But again, this is for total spending, not just for non-durables. Non-durables plus durable goods. Okay, so this is what the counterfactuals look like. I've shown you the one in the preview before. The left panel here, the top is total personal consumption expenditure. The bottom is just motor vehicles. Here, we're just going to show you the change in demand. Right? So no general equilibrium forces. This is really just like the Sam-Shapiro and Slemrod calculation right at the beginning. We're going to multiply the rebate path with the micro MPCs and just subtract it from the data. Right? So no general equilibrium forces here. And so you see these big drops that I've shown you earlier before, followed by a swift recovery. The right panel then shows you what's happening in general equilibrium. Right, so now the general equilibrium forces turn on. Right? And so what you see is, if you just sort of compare the right panel to the left panel, is the drop gets bigger. Right? The general equilibrium forces amplify the decline in consumption. Right? So to the extent that you thought, and for motor vehicles, obviously that same story happens here. These kind of drops are really quite dramatic, right? To have motor vehicle spending, when you have a very high MPC, in GE, it drops by 2/3. And so again, we don't think, based on the kind of analysis we've done, that these kind of counterfactuals are particularly plausible. Maybe you could justify a small drop consumption, but not something that is of this kind of magnitude. If you want to compare it to our forecast, I have the line here. This is our most pessimistic forecast. Again, trying to give it as much information as possible to account for some of the patterns we see in the data. Okay. Now, if you want to put some numbers on this, if you have a micro MPC of 0.7, again, sort of the midpoint of the Parker et al. Estimates, in GE, so 70% of the rebate is being spent at the micro level, but the actual increase in consumption is 1.4 times the size of the rebate. Right? So you get massive amplification here. And that's really because there's a Keynesian multiplier in this economy, right? So one constraint agent spends $1, and then that's going to be some of that is going to go to income to another constraint agent, and they're going to spend $1 and so on. Right? So here, this model really doesn't help us resolve the tension between the micro estimates and the macro MPCs. It actually makes the tension worse. But then how do we address this? We're going to now introduce our main general equilibrium dampening force, which is there's going to be congestions in the production of motor vehicles. What I'm plotting for you in this graph is the black line is the relative price of new motor vehicles, so relative to other goods in the economy. And so what you see around this time, the relative motor vehicle price is falling, right? So there is some weakness in this economy for motor vehicles, but just right around the time the rebates in May 2008, this thing spikes up. So it looks like some evidence that congestion is there in the data. And so we're going to capture that by changing this supply elasticity from infinity to 5. So supply is still going to be pretty elastic. This probably reflects some sticky prices, but this is in line with what the estimates by Goolsbee and House and Shapiro say is reasonable for supply elasticity of durables. When we do that,
Can I ask you something?
Yeah.
For the people who are spending everything every time, in some sense they don't borrow much. So if we believe that the price of the car is big enough, in some sense when you get the rebates, in some sense you are getting money, some borrowing, some sense you are able to invest things that you cannot do in the other times because you don't save much. So what's going on if you assume that the price of durable are or the unity of durable are fixed, so you cannot spend as little as you want? That's in your model is something saying that is a discrete expenditure for durable.
I think that's ultimately what's going on in the micro data. It's like I mean what I think of is like this. The models I've written down in the past is you have an SS model, right? So your durable depreciates and you hit the boundary and then you buy it. And so what the rebate does, even though the rebate is small relative to the price of a car, for some people it will just push them over the boundary, right? And it will induce big motor vehicles spending that way. We don't have that in the model, obviously. You know, it's all smoothed out. I guess I'll say two things in the defense of that, which is at the end of the day, what we care about when we do our exercise is like how much is demand per vehicle goes up. And then the only thing we care about conditional on that is what are the demand and supply elasticities to get at, you know, what are the aggregate effects following that change in demand, and we match that. The other thing I'd say is in terms of, the frictionless model is actually has some work with Alistair where that shows that the frictionless model for sort of durable accumulation is actually quite similar to the way a fixed cost model works, in that both of these models put a very strong emphasis on the user cost, the contemporaneous user cost of the durable good. The main difference between these two models is the interstate elasticity. The frictionless model is much more interstate elastic than a typical fixed cost model. And so we reduce that interstate elasticity in our frictionless model to align with the data. And so we don't think that difference is actually that big in the end, but obviously we haven't done that, right? So I think it's still, and for our purposes, I think we're making the right choices, but again, we're open to arguments for where we're going wrong when we do it this way. Okay. So now we have this congestion. We have the high durable price, and what that does is now, again, the left panel, nothing will have changed relative to what I've shown you earlier. The change in demand is exactly the same. So the only thing I've changed is the general equilibrium force. So the only change will happen is in the right panel of this figure. You see that now, rather than getting amplification, so remember before the drop in consumption was much larger, we now get some dampening. And especially for low values of the MPC, like 0.3, we get pretty significant dampening. Pretty small drops in consumption. Again, say for motor vehicles, for low values MPC, those counterfactuals now look reasonable. And so what's happening is that a lot of people go out, buy cars, that pushes up the car price, and that some people will either delay the car purchase or substitute away from it or not buy it. That's the crowding out effect here. And it turns out that's actually quantitatively important in generating or sort of reducing the tension between the micro and the macro data. So we have an MPC of 0.3. So 30% of the rebate being spent at the micro level. The aggregate increase in consumption expenditures is only 0.19 rebate, right? So it's smaller. You get less spending at the aggregate level than at the micro level because of this crowding out effect. So here in our model, again, for sort of low values of MPC, that now looks reasonable. But obviously, the micro data, the standard micro estimates are much larger than 0.3, or typical ones that are more in the order of 0.5 and 0.7. There you still get substantial increases in consumption and counterfactuals that look, look large relative to what's plausible. So the last thing that I want to focus on is why do we think a micro MPC is reasonable? And make the case that the micro estimates that are this order of magnitude are probably too large, given the data. Before I go up, let me just sort of the summary of this is in terms of thinking sort of broad implications for heterogeneous agent new Keynesian models. Obviously, we did something very simple here. We don't have a lot of heterogeneity of the household side. We still think there's some important lesson here, which is that heterogeneity of goods is also very important for how these models work out at the end. The addition of the durable really is crucial here because general equilibrium forces operate much more strongly in those. They're much more price sensitive than a non-durable demand. Right? And that means that it's not just the overall MPC that's important here for how the aggregate patterns of the model play out, but the distribution of spending matters as well. So heterogeneity of goods is as important as heterogeneity of households, or maybe as important. Now let me go to the micro MPC, and I think this will be actually be able to wrap up pretty quickly. I want to first review the specification, or like what do Parker and his co-authors do? I at the micro level, so at the household level, here this is index by I, you look at the change in consumption between T and T+1. There is a bunch of controls. Those are not particularly interesting, month dummies and household level controls. This is the important part. This is an indicator as do you get a tax rebate in this at T+1. And the timing of this tax rebate is randomly assigned. And so the view then is beta will estimate the causal effect of the rebate. So getting the rebate on consumption expenditures. So to highlight what's going wrong here, when you run this regression, think about the following example. Right? So what I'm plotting here is there's going to be 3 different cohorts, and they're going to get the rebates at different points in time. This cohort will get the rebate at time t. This will get the rebate at time t+1. This cohort will never get a rebate. And so my timings are here. And you should think of these paths as essentially consumption paths. Okay? So here's going to be a cohort that gets the rebate at time t. So at time t, they're going to spend more. And then the consumption will go back to normal, and then we'll just continue that way. And the same with T+1, they're going to spend more at time T+1, and then consumption will go back to normal. Think about what OLS will be doing here. It will see, okay, this group gets a rebate at time T, their consumption growth is big, and it's big relative to my control groups. These guys don't get a rebate at T, and these guys don't get a rebate at time T. So that's one comparison we're making. The other comparison we're making is these guys get a rebate at time T+1. Their consumption growth is big relative to this cohort, but it's also particularly big relative to the previous cohort, right? The previous cohort now has falling consumption because they're just coming off the rebate. Right? This is a counterfactual. This is like a comparison that OLS will make when you estimate its coefficient. And you can see that this is not, you're going to overestimate the effect of rebate because you're comparing this increase with this large drop in consumption that's coming off the previous period. So to address this, we're gonna use the Borjak-Jarvel and Spies estimators. This is actually pretty simple to explain. I think it's much more transparent on what OLS is doing. Is you're essentially going to estimate a counterfactual model for the changing consumption only on the units that are never treated or not yet treated, so that haven't gotten a rebate yet. So you regress in the same control variables. There's no rebate indicator here, right? Because nobody gets a rebate in this sample. Then you predict or you impute the change in consumption for everyone, including those units that have gotten a rebate. And then the treatment effect is just the difference between the realized consumption change minus this imputation. So what you predicted based on the non-treated units. Right? And then you just take an average of this treatment effect and you're done. So, pretty simple way. Let me show you what these estimates look like and how they compare. There's not a lot of time, so I'm just going to focus on the first column. The top panel is the OLS estimator. The bottom panel is this imputation estimator. This is in a full sample. The rebate, this is telling you if you get a rebate. OLS tells you you spend $500 more. The average amount of rebate you get is about 1,000, so the MPC is 0.5. Our imputation estimator, or the imputation estimator, this change in expenditure is much lower. It's only about 300, an MPC of 0.3. That's why you pick 0.3 in the model as well. Where does that difference come from? It's not coming from additional noise, right? The standard errors are essentially the same. It's coming from this comparison with previously treated groups. It's called a forbidden comparison in the literature. And so the way we can make that clear is we can essentially look at the overall treatment effect as combinations of treatment effects at different points in time. So the points in time here, June, July, August, this is when you're being interviewed and when you've told the CX that you've gotten a rebate in the previous 3 months, right? So somebody in June gets interviewed. They said, I got a rebate in the last 3 months. That would usually be May in this case. And you can see if you compare the people who got a rebate in June, they'll spend about $600 more than the ones who do not. So this is a comparison between treated and those who've not gotten a rebate yet, not yet treated. The imputation estimator is essentially the same magnitude. Right? There's really not much of a disagreement here. You can repeat it in July, you can repeat it in August. There's really no disagreement between these estimators. The big disagreement comes in September. Right? What's happening in September is, well, you compare people who get a rebate with ones who do not, but the ones who do not include both people who have not gotten a rebate yet, that's the black bar, and a comparison between people who've gotten a rebate 3 months ago. Those people come back into the sample. So this cohort here was back into the sample as a control group. And so OLS sees that and sees like, well, these guys spent a lot in June. Their consumption is falling now going into September. And so it estimates a big positive treatment effect as a result of that. the imputation estimator does not make that comparison, and so that's not there. You can calculate, okay, how much does this bar alone account for the difference? We have that in the bottom right panel over here. That's $150 of the total effect is just coming from this particular comparison. The overall difference was about 200, 3/4 of that is just coming from here. There's some other ones coming from weights. Again, we think those from the imputation estimators are more reasonable. At the end of the day, much of the difference or this upward bias here really comes from these kind of forbidden comparisons. You're making an improper comparison with previously treated units. Most of the change, I'm happy to talk more about this later, but I'm already out of time. Most of the change comes from non-durable expenditures. It turns out for vehicles, the expenditure patterns are actually pretty robust. Again, when you feed in the micro MPC into a model of 0.3, G MPC is 0.19, you can think of that essentially as being the multiplier in the model as well, because investment really doesn't do very much, other sources of, and so what this is telling you is that the multiplier essentially for a tax rebate in our model, which we think generates reasonable counterfactuals that is consistent with, we think, are better microestimates. The macroeconomic effects of tax rebates are ultimately pretty modest, with a multiplier of 0.2, just slightly below 0.2. So with that, that's all I have to say. So what have we done? We've created these counterfactuals with a two-good, two-agent new Keynesian model. We've argued, at least the baseline, they're not plausible. We reconcile the micro and the macro data in two ways, or by combining two different approaches. One is this general equilibrium damping force through congestion in motor vehicles, and then showing that there's an upward bias in the standard OLS estimates for the micro MPCs. Ultimately, at the end of the day, what it suggests is that the aggregate effects of rebates are going to be sort of more modest rather than powerful, in contrast to what sort of previous literature has said. More generally, we think that this sort of joint micro-macro perspective is actually a pretty useful way for evaluating micro estimates and a particular plausibility of micro estimates. So with that, I'm going to wrap up. Sorry, I ran a little bit over time, but I'm happy to take any questions and stick around a bit longer as well.
Thank you so much. So we have about 10 minutes left. So if you want to ask something or make a comment, just jump in.
I have one question. Maybe it went too fast, but like at the end you have, like with this DID imputation, you have an MPC of around 0.3, and when you try to match that MPC in your model, you still get like more than forecast, like a reduction that is larger than the forecast, right?
Let's see. So that is actually no. So the blue line is going to be our 0.3.
Okay, so you match it. Okay. Yeah. Okay. Yeah. So that's the thing that I wanted to clarify. Thank you.
So Ernesto here, I'm wondering whether there could be some exercise to do some external validation to the GE mechanism. For instance, one possibility is, as Jorge was suggesting before, using geographical variation or showing what's going on with prices or something.
Yeah, I mean, so the price, so the increase in prices here is about relative to trend, so it's about 1.5%. So the model kind of produces that kind of similar magnitude. So MPC 0.3, which is sort of a baseline, you're going to get that about 1.5% increase in prices. Obviously, when you have bigger micro MPCs, those forces are stronger, right? And so then you get into ranges of prices that I don't think are empirically realistic, but again, we argue that this is part of the more plausible path. So, I mean, the regional thing is tricky, right? Because again, like you have to think about whether the congestion externality operates at the regional level, and my guess is probably somewhat. I don't really have a good sense of what the strength is, right? So if the problem is you cannot produce enough cars quickly enough, then that's probably something at a national level. If the problem is the sort of local stockouts of injury, that's going to be a local issue. inventory, or if there's some the places can't hire enough people at the car dealer, that would also be a lot. So
I was thinking more on the I don't know how things work in the US, but extrapolating what happened here, probably all car sellers from a given model of a given brand have a list price, and it's going to be the same regardless where you buy it. And if for some reason, if you are able to get some local data on purchases, that could give you a sense of, and of course the rebates going on those local markets, then can give you a sense of whether these G effects are really playing a big role.
Yeah, I mean, so I think it works slightly different. I mean, but so where would the variation in the G effects come from? Right, if everyone pays the same list price. But the issue is that the list price is going up. I actually don't think that that's probably not the main mechanism. My guess is what's happening is that because list prices are super sticky, they generally don't change by model. My guess is that they are reducing incentives, which is sort of some rebates on the car, and then the dealers start throwing some. So when I went to buy my last car, I went to the dealer. The list price of the car is $20,000, and then the first document I get is like, the price of your car is $25,000, and it's like $5,000 of options that are worth like $20 that were thrown on top. And I think that's mostly the margin that actually they operate. That it's that they're kind of exploiting that kind of price discrimination, essentially.
Okay, I see. Yeah.
Another reason to believe that that's what's going on is the BLS produces two series for new vehicles, two price series. One is just the standard prices they've had for many years, which is the way that works is they call up the dealers and they say, like, price out this model, price out that model, price out this model, and then they compare it to what happened in the previous month and see some differences. It's more complicated than that, but it's probably like this is the way they approach it. And then the other, the new research series, which is going to be replacing the old one in the CPI, is based on actually a sample of transactions. So that they went to, I'm trying to remember which company it was. Maybe it was TrueCar, like one of the big companies that collect sort of actually motor vehicle transactions. So then they actually have the real prices that are being paid for 250,000 vehicles every month, and that's where you actually see the big spike up. You don't see it in the series that the dealer priced for you, because yes, they didn't feel like, or maybe they were just moving. I don't know exactly what they were going on, but you really actually have to look at the transactions paid, and you have to have a pretty detailed data set to estimate the price response as well. So anyway, long these. I would really like to continue, because I still don't quite see exactly how we can get. I would love to figure out a way how we can do it at the regional level, but the problem I see is like we're probably going to see pretty similar changes in demand everywhere, and from the rebate, just because it's mostly, I guess it's mostly based on demographic characteristics and income. I don't know. There's going to be a lot of variation here to exploit to get at differences in demand, plus then measuring the differences in congestion at the local level. Anyway, if somebody has ideas, I would love to hear it, because it would be great if you could say anything about it.
Yes, I think what they use is the heterogeneity in the housing shock, basically. So you have in some places demand is more contracted because of house pricing going down further, right? So I think
I see. And so the idea is then that the congestion externalities are smaller there. Is that the view, or?
No, what I just was just telling you the mandatory in 80 from the housing market, not thinking of the congestion externality that you have.
I see.
But they might relate.
Oh, okay. So it's the drop in house prices and the effect on car purchases.
Right.
Okay.
Right.
So Johannes, two comments. One short comment related to this is there's this paper by Aronson, Agarwal, and French who look at minimum wage changes. So that's very different because it's not strictly speaking something like a rebate, but they argue why this can be interpreted as a short-lived shock to the households that actually receive it. And then I guess they have more variability between states because they exploit variation in minimum wage changes across states and time. So there is less likely to be a countrywide general equilibrium effect, perhaps, than for these stimulus payments. So they get a sort of MPC out of this response to minimum wage changes, arguing that this affects households for a short period because they move away from minimum wages anyway in a few years, in a few quarters actually.
Yeah.
So this, I mean, I guess it's less clean because it's strictly speaking not a shock, not a pure transitory income shock like a rebate. But there is an argument that they make why this can be interpreted somehow related. I mean, they just document the response. But and the other comment is like, it feels to me in the end, after seeing everything, that the paper is kind of told in reverse, the story, in the sense that if I go through your 4 points, it's like you could present the difference saying, look, first of all, there is an econometric argument why the micro MPC is not the micro MPC. There is a better estimate of the micro MPC. Then you have a model that with a particular general equilibrium channel can make sense of what you see in aggregate data and your corrected empirical MPC. And after that, perhaps there isn't as much room. I understand that these other numbers for the MPC are very influential papers. So the discussion about whether they make sense with the aggregate data, maybe that's the historical way in which you constructed the paper. You started seeing the compatibility with the aggregate data and then eventually arrive at the root cause of the issue. But now that you have the full picture, it feels like you could build this from the empirical MPC to the model that is consistent with it. And maybe there is less of a need to discuss that the micro MPC of 0.7 is inconsistent, or the narrative about the crisis, because at the end of the day, the micro MPC is 0.3. I mean, to the best, the best estimate that you have is 0.3.
That's fair. We've been debating the same. So, thank you. That's a useful input in the discussion.